Hi guys, I am going to try and give you some quick examples on things that you're going to see on that practice for converting SI units and scientific notation, all that jazz. First thing you're going to want is your table. This is the same one that I'm linking in for you. The main thing you're going to want to focus on is this middle section, that kind of, honestly not even giga really, but like giga to pico, that sort of middle region, that's where we live. Thing to note is that on that micro line, it has the symbol and it says mu and u, but there's actually a Greek symbol that I would prefer you use just because when you write it out, it'll look better. Plus, it makes you feel cool. So I'll show you that in a second. Let's dive into those example problems. I've got 4 problems I want to do with you. First one, we're going to need that micro symbol anyway. How many microseconds are in 1 kilosecond? So let's start writing out, hey, what is a microsecond just in seconds? Okay, so 1 microsecond, there's that Greek symbol mu, is the same thing as 1 times 10 to the negative 6 seconds. And then 1 kilosecond, that is the same thing as 1 times 10 to the 3rd power of seconds. Okay, great. So we want to get from 1 times 10 to the negative 6 to 10 to the 3rd. So that means we're going to have to move over 9 steps, but let's not get into that. Honestly, the easiest way to do this by hand, and you're thinking, don't just look this up, don't look it up. It's a waste of your time because you're going to have to be able to do this on the exam at some point, and you won't have Google this, so you may as well not use Google now. Okay, don't say I didn't warn you. Let's write this out. So I have my 1 times 10 to the negative 6, so that means 1, 2, 3, 4, 5, and then decimal. And then you should always have a 0 before your decimal, just so you know. That's just proper form. So I want to get from this value, 1 times 10 to the negative 6, or 0.000001 to 10 to the 3rd power. So that means I'm going to have to move my decimal over 3 more times. Since I'm going from something smaller to something bigger, I need to move my decimal over to the left. So let's take that decimal, and we're going to move it over 1, 2, 3 more times, because it's 10 to the 3rd power. So, and I'll fill in my extra zeros. So that means I'm going to be left with 0.123 zeros, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, and then our 1. Great. Now we've got this in kiloseconds. But you're not going to want to write this the entire time, so we are going to move our decimal over again and put this in scientific notation. So since I want to go and just put this in the easiest form possible, I just want to get it so that it's 1.0 at the end. So that means I need to move my decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9 times, so my decimal ends up 1.0. When I do that, that's 1 times 10 to the, since I moved it the other way, positive 9 kiloseconds. Okay, so that's going to be our final answer. This is kind of confusing. The easy way to think about it is since you're going from something smaller to something bigger, you're going to have to move your decimal over. So you're just going to need to add these 2 exponents. Now, you're going to have to take your negative 6, and then so you're moving it over 3 more times. I guess you're subtracting. Subtract 3, so it's 9. That's how you get 9. Kind of confusing. I'm not a math teacher. I'm sorry. This should be just review anyway. Let's move on to our second question. Convert this value in milligrams to the base unit. So, sorry, not milligrams. That's megagrams. You see how it's a capital M? Mega. So mega is megagrams. That's the equivalent of 10 to the 6th power. So that means that this is really 0.00000000000 675 times 10 to the 6th power. That's what we've got, which means we need to move our decimal point over 6 times to get back to our base unit. Since we're going from something bigger to something smaller, we need to move our decimal back. Okay. The other way we did smaller to bigger. This way we're going bigger to smaller, so we need to move it to the right. So let's count it out. Since we want to go back to our base unit, that's 10 to the 0. We need to move it over 6 times. So we're going to go 1, 2, 3, 4, 5, 6. That means we're going to be left with a value of 0 point. So we've got to have that 0 point in front. 6, 7, 5 grams. That's our base unit. And you're done. Cool. Next one. This is another base unit problem. I've got 487,586 nanometers, and I want to get to my base unit. Since it's nanometers, I want to get to meters. So let's write it out. First thing we should know is that nanometers is the same thing as 10 to the negative 9. So let's write that out totally. 4, 8, 7, 5, 8, 6. But then I got to move it over 9 times. Let's see. How do I want to do this? Three, 4, 5, 6, 7, 8, 9. All right. So that's kind of confusing to read. I moved it back because I'm going from a smaller unit to a bigger unit. So I'm moving my decimal to the left. And I just wanted to get from my 10 to the negative 9 to 10 to the 0. So I just moved it over 9 times. So let's rewrite this as 0 point. We're going to have that in front. 0, 0, 0, 4, 8. And I'm actually going to round here. 488 meters. Now we've gotten to our base unit. You could have written all the other numbers out. I'm not going to. I'm just going to round it for today. And this would be, for the record, since you have 3 numbers behind the decimal that are zeros and then another 3 numbers, 3 plus 3, you have 6 significant figures. If we go back to our old problem, you only have 3 numbers behind the decimal. That is 3 significant figures. That 0 out front, that doesn't count as a significant figure. Okay, let's do our last problem. This is one that I would say is also rather tricky just because you have extra steps and you have to think a little bit more. So I've got 0.000000685 meters, and I want to convert it to scientific notation and pick prefix. All right, so I'll just go and say that you have 2 options. They're both pretty good. I have a preferred one, but either one works. If you look at that table, we'll go back to it, you'll notice that there's a 10 to the 6, or a 10 to the negative 6, and a 10 to the negative 9. There is nothing in between that's going to give you a prefix. So you need to either pick micro or nano as your prefix. I'll do both, just so you can see. Let's do the micro first. So we're going to write out our number. 0, 0, 0, 0, 0, 0, 6, 8, 5, our decimal. We're going to make this negative 6. So we're going to move our decimal. We're going from a bigger number to a smaller number. We're going to move our decimal to the right. 1, 2, 3, 4, 5, 6 times. So that means that this is going to become 0.685 times 10 to the negative 6 power, which that, when you could select a prefix, you drop that times 10 to the in your exponent, and you're left with 0.685 micrometers. Okay, so this one with the scientific notation, that's meters. But when you drop the scientific notation, you need a prefix to tell me the implied notation. So then you have to have micrometers. Let's convert it to nanometers. Same process. We have to write out our number. The But this time we're going to move our decimal over 9 times, because times 10 to the negative 9th, that is nano. So we got to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to give us 680. Oops, was it supposed to be 5? It was supposed to be 5 now. 685 times 10 to the negative 9 meters, which is the same thing as 685 nanometers. Hopefully these examples help you along. If you're really confused, please see me. Again, I'm not a math teacher, but you do need these skills in this class, so hopefully we can kind of help each other along.